second derivative test, we have a function fx equals to minus 3 by 4 x to the power 4 minus 8x cube minus 45 by 2 x square plus 105. So we have this function, and we want to collect the point of maximum, local maximum and local minimum, and their values also, maximum and minimum values also. So local maximum and minimum and maximum and minimum values. So we will use second derivative test. According to this, first we have function, then we get first derivative, then put f dash x equals to 0, solve for x, find the values of x, then second derivative, then values of x put in second derivative, and if f double dash x greater than 0, positive, then it will be local max, and when it is positive, then it will be local minimum. If it is 0, then point of inflection. So it is a simple second derivative test. So first we will obtain f dash x. So we will derive this equation, that becomes minus 3 by 4 into 4x cube minus 8 into 3x square minus 45 by 2 into 2x and plus 0 of 105. So it will be, cancel out this, minus 3x cube minus 24x square minus 45x. So on taking common 3x, so we get x square plus 8x plus, what about this, this is 45, so this is 15. Now factorize this, so we get x plus 3 and x plus 5. So this is f dash x. Now this is step 1. Now step 2, we put f dash x equals to 0. So minus 3x x plus 5 x plus 3 equals to 0, and getting the values of x, so these will be x equals to 0, it is minus 3, and one more, x equals to minus 5. So this is our step 2, and now we will check maximum and minimum values and minima, local maximum and local minimum points. So for extremum points, means local maximum and minimum. So first we will take any value of x. So first we are taking case 1, x equals to 0. We have f dash x. F dash x is, that is 3 x cube minus 24x square minus 45x. So first we will obtain second derivative, so it becomes 9x square minus 48x minus 45. So it is second derivative, and according to second derivative test, this is the deciding factor on which we will get the extremum points. So when we take x equals to 0 and put this value in this function, so we get f double dash 0. So we get negative value. So if it is less than 0 value, then it shows local maximum. So it is the point of local maximum. So the maximum value at this point, so we put this value in the function, so it will be f0. So when you put this value in function, then you get 105 as a maximum value. So first answer on first point is this. It shows local maxima, and this is the maximum value. Now case 2, we will take the second value. So it is very easy, and our next value is x equals to minus 5. So again we put this value in second derivative, so f double dash minus 5. So on putting this, 3 into minus 5 cube minus 24 into minus 5 square minus 45 into minus 5. So on solving this, we will get the value minus 30. Again it is lesser than 0. So this shows at this point function shows local maxima. Maximum value will be, that is f minus 5 when you put this in the function, given function. So on solving we get the value 295 over 4. So this is the maximum value, and on putting this value in second derivative we get the negative value or less than 0. So it shows x equals to minus 5 curve shows local maximum. So the maximum value is this. So this is the second answer. Right now we go for third, and third point is case 3, that is at x equals to minus 3. So f double dash minus 3, so we put this value in the second derivative, so we get 18, which is greater than 0, or you can say positive. So f double dash minus 3 is positive. If it is positive, then this is the point of local minima, and at this point the local minimum value, so minimum value, that will be f minus 3. We put this value in the equation of function, or you can say given curve. So on putting this value, then we get f minus 3 equals to 231 by 4. So this is the minimum value, and this shows the point of minima. So this is the answer. We have a equation of curve fx equals to x cube minus 6x square plus 9x and plus 15. And question is same, find the point of local maxima or local minima. And maximum and minimum values. So we have these two tasks, and for getting these values we will use second derivative test. So according to this, step 1 is first we obtain first derivative. So first derivative means differentiate this, you get 3x square minus 12x plus 9. So it is 3 common, x square minus 4x plus 3. So it is x minus 1 and x minus 3. So these are the factors. Now step 2, we put f dash x equals to 0 and getting the values of x. So f dash x, that is thrice of x minus 1 and x minus 3. So we put 0. Now we get the values of x equals to 1 and x equals to 3. Now third point, we obtain the second derivative. Because this is second derivative test, so all checking of maxima minima will occur on second derivative. So we differentiate this. Right now we get 6x minus 12. So it is our second derivative. Now we have these two values, x equals to 1 and x equals to 3. So we will try to obtain maxima and minima and maximum and minimum value on these points. Now we have function fx is x cube minus 6x square plus 9x plus 15, and f dash x we obtained, it is 3x square minus 12x plus 9, and second derivative is 6x minus 12, and we have the points x equals to 1 and x equals to 3. Now we check maxima and minima on these points. So case 1, at x equals to 1. So we put this value in second derivative. So f double dash at x equals to 1, it will be 6 into 1 minus 12. So we get minus 6, that is negative or less than 0. So it shows the point of local maxima. So the maximum value will be so we get f1, we put this value in the function, so it will be 1 cube minus 6 into 1 square plus 9 into 1 plus 15. So it will be minus 6, and this is 10 and 15. It's 25 minus this, we get 19. So this is the maximum value. Now case 2, at x equals to 3 on this point. So f double dash at x equals to 3 will be, put this 6 into 3 minus 12. So we get positive 6, or you can say greater than 0. So it means this is a point of local minima, and the minimum value will be that is, we put x equals to 3 in the equation of function. So it will be 3 cube minus 6 into 3 square plus 9 into 3 plus 15. So we get the value of this function at 3, that is 15. So this way we will get the local maxima and local minima and their maximum and minimum values.